Okay, so here we go. We've got a problem with a owner of a horse farm, and she wants to build a corral for her horses. And we want to build it so she's got it's against a barn. So pretend this is the barn. Move this out of my way. Here's the barn. And then we're going to build a corral. So it's going to be like, okay. So these green lines, those are the only pieces of fence she needs to use. So what we're going to do is, because we want to find the maximum area, we know that our primary equation is going to be an area equation. And because it's a rectangle, we know it's just going to be area equals length times width. All right, so here we go. I'm going to make this side X and this side X. And now I have 200 feet of fence to use, so this last length is just going to be 200 minus 2x, because I've already taken off 2. So now I'm going to plug these guys in. So I've got area equals distribute the x. Now I'm going to take the first derivative. Area prime is going to be 200 minus 4x. Now this is pretty straightforward. When we set it equal to 0, it's just going to be 4x equals 200, and we get an x value of 50. So that means that 50, and then if I plug the 50 back here, 200 minus 100 is 100. So that tells me that the dimensions are going to be 50 feet by 100 feet. All right, let's take a look at number 4. You can do number 3 on your own. Postal requirements specify that parcels must have a length plus girth of no more than 84 inches. Find the dimensions of a square-ended rectangular package of greatest volume that is mailable. Now remember, girth is the distance around the package. So what we're going to do is we're going to imagine that the bottom of our rectangle is going to look, here's the bottom of our package, right? Now, we know that we are maximizing volume, and it's a box, so volume of a box, length, width, height. Here we go. So I've got, here is x for one side, and here is x, and here I've got, let's see, if all this has to add up to 84, let's think for a second. So if I called this y, which I really don't want to do, but I'm going to, just for fun, I'm going to call it y. All right, so now we've got 2x plus 2y has to add up to 84. If I solve this for y, I would get y equals negative x plus 42. So that's what I'm going to put over here. I'm actually going to even erase the little y equals because they're confusing looking. All right. So the volume of my box is going to be length width. The only thing I don't have is height. So either the square is on this side or the square is on this side. Now I'll be honest with you, this side could have been the shorter one. I didn't draw this to scale, I don't know. But we're going to pretend the square is over here just to make life easier, and this becomes an x. So now multiply it all together and we get volume equals negative x cubed plus 42x squared. So now I'm going to take the first derivative. So we've got v prime equals negative 3x squared plus 84x. Set that equal to 0. Oops. I'm going to take out negative 3x. I'm going to be left with x minus 28. And I have possibilities of x equals 0 or x equals 28. Now obviously it's not 0, so I know that one side is 28. So let's see. If I put the 28 here, I get 14 because negative 28 plus 42 is 14. So I know that my dimensions are 28 by 14. Now we have to think for a second. Either I have a square of sides 28 or I have a square of sides 14. If my girth is no more than 84, I can't do a square of size 28 because it's going to be too big. Because 28 times 4, if that square was the 28, it would be 112 because 4 times 28 is 112. So obviously that's not correct. So it's going to be 28 by 14 and then the square has to be the 14. Right. We're going to get one more problem together. We're going to look at number 6. Again, you are skipping number 5. All right, it says 1,000 feet of chain link fence will be used to construct 6 cages in a zoo exhibit. So it says find the dimensions. So we want to maximize the area. So, and again, it's area. So my primary equation is I want this to be the maximum area. So my first derivative is going to end up being A prime. Problem is I really can't have it like this. So what I'm going to do is I'm going to add up all my fence. So if we have X is this length, we have 1, 2, 3 X's we're using for our fence. So we have 1,000 is going to be 3X, and then we've got 4Y, because look, we've got 1, 2, 3, 4 pieces that are this length. So it's going to be 3X plus 4Y, whoops, I don't know what that's all about, plus 4Y. So now if we solve this for X, or for Y, subtract, so we've got 1,000 minus 3X equals 4Y, and then divide by 4, oops, we get 250 minus 0.75X equals Y. So that's kind of like our secondary equation. We're going to plug that in, and we've got area equals X times 250 minus 0.75X, distribute, oop, let's take our first derivative. So that'll be 1.5X, and then set it equal to 0. 1.5X equals 250. Grab our calculator and divide, and I get 16.6, oops, not 16.6, 166.6 repeating is X. So now I'm going to do for Y is I'm going to plug this number here, and I end up with Y is about 125. So my answer is 166.6 feet by 125 feet. So go ahead and finish any problems we haven't from pages 7 to 9.